Now we want to use those fundamental identities, those basic trig identities, to verify trigonometric statements like this one. This one says that sine x times cosecant x equals 1. That means no matter what value for x we choose in the domain of sine and cosecant, we're always, this expression right here, sine times cosecant, is always going to be 1, no matter what. This is not an equation where we're looking for a value of x where this is true. We're saying this is always true provided we're in the domain of both of these functions. No matter what we put in for x in the domain, we're going to get 1. So what we want to do is we want to, it might not be obvious here, but what we want to do is use those trigonometric identities, the basic ones, and see if we can simplify the most complicated side to equal the other side. In other words, I've got sine times cosecant. So I'm going to come over here. I've got sine x times cosecant x. And I'm just going to work with one side. So I take one side of this, and I start making substitutions in here, and hopefully I'll get to the point where this whole thing is just equal to 1. Hopefully I can show that. Now, one technique for doing this is to change everything, to change every trig function that you see into either sine or cosine. This is just a trick. Now, you don't have to think about that in this case because you can see clearly that I could write cosecant as 1 over sine. But nevertheless, let's just think about this. We've got cosecant as 1 over sine. Notice I've written cosecant in terms of sine. Okay, so I did that. Now notice, this and this cancels, and I'm just left with 1. Well, that's exactly what we wanted to show. So that's how this game is played. Pick the most complicated side and start making substitutions. And like we did here, we started with this complicated side, sine, cosecant. We made a substitution in here, and then we noticed that sine divided out and it equaled 1. So we have verified that identity. What we did was we verified, yes, this is just another way of saying 1, provided we're in the domain. Okay. Now let's look at this one right here. We have tangent cosine, tangent x times cosine x, and we want to show that that's always equal to sine. So once again, we take the complex side, the tangent x cosine x. And what I'm suggesting to you, and this is just something that you can do, just write what you can in terms of sine and cosine. Now, here you can see I can rewrite tangent as sine over cosine. So let me do that. Sine x over cosine x. And notice you're just following the equal sign along. So I start here, and what I want to end up with is sine. And sure enough, look at this. These cancel, and we're just left with sine x, which is exactly what we wanted to show. Okay, let's look at this next one. Here we've got tangent x plus cotangent x equals secant x cosecant x. Okay, so what I'm going to suggest is we start over here with tangent x plus cotangent x. We don't write both sides. Let's just start with one side. Now, I'm going to convert everything to sine and cosine. So tangent becomes sine x over cosine x. Cotangent becomes cosine x over sine x. Yeah, like that. Now, okay, so you might look at that and say, well, now what? We're stuck. Well, we could add these two, right? Notice I've got sine over cosine, cosine over sine. Let me get a common denominator. That means I need to multiply the top and the bottom of this one by sine. I get sine squared x over cosine, sine cosine. See? I just multiply the top and the bottom of this by sine. And likewise, I'll multiply the top and the bottom of this by cosine. So here's what I got now. I've got cosine squared over sine x cosine x. Now, the thing is, notice we have a common denominator here. Okay? We have a common denominator, sine x, cosine x. So that means I can put these two together, and I've got sine x, sine squared x, see, plus cosine squared x, okay, over sine x, cosine x. Now, this is an identity you'll use over and over again. Sine squared x plus cosine squared x equals 1. So what we have now is we have 1 over sine x cosine x. Okay, see? And 1 over sine is cosecant, 1 over cosine is secant. So looks like what we have here is cosecant x, secant x. See? I just kind of view this as 1 over sine times 1 over cosine. And I got that. And that's what we wanted to show. Remember, that was the identity that we were looking for here. Okay, now let me, okay. Okay, now what about this one? We've got secant squared theta minus 1 over secant squared theta equals sine squared theta. So I want to see if I can figure out a way to show that this side is always equal to this side. So I'm going to start with the complicated side here. I've got secant squared theta minus 1 over secant squared theta. Now there's a couple of ways to proceed with this. I think what I want, you could immediately recognize this top is tangent squared theta. And then you have tangent squared over secant squared. Or you could do this. You could break this up. And that's what I'm going to do. I'm going to put secant squared theta over secant squared theta minus 1 over secant squared theta. Okay? Now, remember, there's not just one way to do most of these. Another way I could have started off, I could have said, well, secant squared theta minus 1 is tangent squared theta. And that's one of our Pythagorean identities. But I didn't choose to do that. I went this way. Now notice what I get there. This is 1. Okay? So this is 1. This right here is 1. This is cosecant squared. No, cosine squared, I'm sorry. See? 1 over secant is cosine. So now I've got 1 minus cosine squared. See that? Because 1 over secant is cosine. And that will give me 1 minus cosine squared is sine squared. Yeah, so there we have it. That's what we wanted to show. We wanted to show that this gives you this. And that's what we did. Okay, now let's look at this last one over here. We've got this one. We've got 1 over 1 minus sine y plus 1 over 1 plus sine y. And we're told that that can be, that's just equal to 2 secant squared y. Well, so I'm going to start off with the complicated side, as usual. We start off with the complicated side because we have something to do with that side. A lot of times it's easier for us to see a path. Okay, so I've got this complicated side. Now, what it looks like I need to do here is add these fractions. See, I've got a fraction. I've got 2 fractions, so I'll add them, and I need a common denominator. Well, I've got 1 minus sine y here, 1 plus sine y here. So let me add these. I need to multiply the top and the bottom by 1 plus sine y here, 1 minus sine y there. So let's see what we get here. Okay? Over here I get 1 plus sine y over 1 minus sine y, 1 plus sine y. See? For this one, I just multiply the top and the bottom by 1 plus sine y. See? Now for this next one, I'm going to multiply the top and the bottom by 1 minus sine y. So here I go. I got 1 minus sine y over 1 minus sine y. Actually, yeah, okay, never mind. And 1 plus sine y. Okay? So for this one right here, I'll multiply the top and the bottom by 1 minus sine y. There it is, and there it is. Okay? Now, let me combine these because I've got the common denominator, so let me combine these. I've got 1 plus sine y plus 1 minus sine y all over 1 plus sine y, 1 minus sine y. Well, 1 minus sine y times 1 plus sine y, those are just conjugates, right? So I can rewrite that as 1 minus sine squared y. See? Now that's cool because look at this. 1 minus sine squared y, well that's cosine squared y. And up here, look what I've got. I've got the sines, they get rid of each other, plus sine and minus sine, and I've just got 2, so I've got this, 2. Now remember, we're supposed to show it looks like this, secant squared, but we don't have that. We have 1 over cosine squared. But 1 over cosine is secant. So this is 2 secant squared y. And there we have it. What we've done is we've verified this identity. So look, there's a little bit of an art to this. There are certain little tricks that you can use, like converting everything to sine and cosine, adding fractions like we did here. But the important thing is, as you're working through these, you try something. And there are different techniques that will work. Oftentimes there's not just one path. But what you want to do is you want to just start writing. And sometimes you'll hit a dead end. But still, you want to try something. And having these identities memorized will help you to identify what to do, what path to take.